Hello, everyone. Thanks so much for coming out to Full Stack Academy today. My name is Edward Hill. My colleagues are Aria Harris, Reiko Lee, and Ben Zerko. Our app is a 3D multiplayer game inspired by the classic film Tron, aptly named 3D Tron. In 1982, Tron made motion picture history by being the first movie to make extensive use of CGI graphics, including the famous light cycle sequence. The light cycle sequence inspired its own spin-off game and has become an iconic part of gaming culture. In the game, a player guides a light cycle around an arena, avoiding walls and trails of light left behind by other players. Our app sought to pay homage to this classic game design by taking it into a new 3D arena where players can turn left, right, up, or down, and compete to be the last rider standing. From here, I'm going to turn it over to Reiko, who's going to run us through gameplay.
First, you need to fill in your name, and you'll click Enter. And it will bring you to the lobby room where you'll be able to chat with other players while you're waiting for the game to start. You click Join to be ready, and there will be a checkmark appear right next to your name. Once everyone is ready, the game is on. So in the game, you can control your light cycles by using the arrow keys for directions, and the light trails will be created right behind your light cycle. And crashing with the walls and the light trails created by other players and yourself will end your game. But don't worry, you can continue to watch the game by using a mouse to manipulate your view. And once everyone is dead and there's a clear winner, the game will be reloaded to the landing page. Right now, I'll pass on to Aria to talk more about our technologies.
Our team wanted to learn and explore new technologies for our project. After deciding to make a video game, we chose to use WhiteStorm.js, which is a 3D rendering framework built on top of Three.js and Fizzy.js, and simplifies a lot of potentially complex problems you can have in game development. Our main challenge was being able to sync up all the players and know about every player's actions, such as turning and collisions. We needed to know about a change in velocity and orientation. To solve our problem, what we did was we used two Redux stores, one on the front end, one on the back end, and WebSockets to communicate between the server and the front end. Having a Redux store on the back end allows us to keep track of the state of our game and keeps all the players on the same page. As an example of the information flow of our app, say I want to turn. So when I hit the key, before I actually turn, what happens is I emit an event to the server. The server receives that and emits that back out to everybody, including myself. And once everyone receives that, then I'll see myself turn, and as well on everyone else's screen, they'll see that I've turned. I'm going to pass the mic on to Ben, who will speak about the physics and turning calculations of our game.
Hey guys, so one of the big questions we had was how to turn. And now WhiteStorm.js gives us two vectors that we care about, an up, or where's the sky vector, and our linear velocity vector. Everything in our game is calculated off of these two vectors, including camera position, bike rotation, et cetera, light trails. And in essence, if you know those two vectors, you know everything. So the question of how to turn becomes, how do we change these two vectors? Now we know the magnitude of these vectors as well. So speed is constant along one of our axes, and so is up. Now, we can narrow down our question more to the direction of these vectors. Now, up and down are a relatively simple geometric transformation of our previous up and velocity vectors as seen on this screen. Turning left and right, however, is a little bit trickier. So when you turn left and right, your up isn't going to change. And so that's easy enough. However, we have no information from our prior up or velocity vectors to give us anything in our direction of going left or right. So what do? And actually, in linear algebra, there's exactly an operator for this, and it's called the cross operator. Cross operator takes two vectors and finds a mutually orthogonal vector. So for instance, if you take the x-axis and you cross it with the y-axis, you get the z-axis, which is perfect for us because then we can take our velocity vector, cross it with our up vector, and get our right-hand direction for velocity. Negative is for the left-hand turn. Isn't math fun?
So thank you guys all for coming out and checking out our presentation. Over the course of the past 3 weeks working on this, we've really identified the importance of teamwork and communication as one of the things that we really took away from this. Early on in the project, we set expectations around what it meant to be a team member, and also adopted an agile development framework so that we were able to meet our goals throughout the project. In the end, we were happy with the app that we developed, and we're proud to have teammates that we can now call friends. Thank you so much for your time.